All right, let's jump into our deep dive today. We're going to be tackling the world of electrical installations. Specifically, we'll be using the British standard BS 7671.2018 as our guide. Now, I know what you're thinking. Electrical installations. Doesn't sound like the most thrilling topic. But trust me, this stuff is way more relevant to your everyday life than you might think.
Absolutely. I mean, think about it.
Yeah.
Whether you're simply plugging in your phone charger,
Yeah.
or, maybe you're planning like a major home renovation. These regulations, these rules, they're quietly working behind the scenes, keeping us safe.
Yeah, exactly. It's kind of like a hidden world of safety that we don't often think about, but it's so important. So for this deep dive, we've got excerpts from the standard itself, BS 7671.2018, that's the one. And we've also got some helpful guides to make sense of it all. I mean, it's a pretty dense document. But don't worry, we're not going to bore you with every single detail. We're going to focus on the recent updates, the 2018 stuff, and, the parts that really matter most to you. Think of it as your crash course in Electrical Safety 101, but way more interesting than, sitting in a lecture hall.
Yeah, absolutely. And to make it a little less daunting, BS 7671, this big document, it's not just a random jumble of rules, right? It's actually organized pretty well. It's got chapters and sections, and each one of those deals with a specific aspect of electrical installations.
Okay, that does make me feel a little less intimidated. So when we talk about electrical safety in our homes, where do we even begin? What's the first thing we should be thinking about?
Well, I think it makes sense to start with the most obvious danger, the thing we all want to avoid. Electric shock. And luckily, Chapter 41 of BS 7671 is all about that, protecting you from those, unwanted jolts. And the core principle, the big idea here, is what they call automatic disconnection of supply.
Automatic disconnection of supply. Okay, that sounds pretty intense. Can you break that down for me? What does that actually mean?
So picture this. There's a fault in your wiring. Something happens, something that could potentially, give you a really dangerous shock.
Yeah.
Automatic disconnection means the system is designed to shut off the power instantly. Like before you can even react, the power's gone.
So it's like a super fast reflex that saves you from getting zapped.
Yeah, precisely. But the real question is, how does the system even know there's a problem in the first place? How does it react so quickly? Well, that's where things get really interesting. That's where earthing systems come into play.
Earthing systems. Okay, that sounds a little bit sci-fi to me, if I'm being honest.
Maybe a little, yeah. But it's actually pretty straightforward. You got to think of the earth, like the ground beneath our feet. Think of that as a giant safety valve for electricity. And these earthing systems, they're like pathways, different pathways, that direct any stray current, any electricity that's not where it's supposed to be. They direct it safely into the ground. It's preventing it from, finding its way through you, which is what we want to avoid.
So it's like a safety net built into the wiring itself, ready to catch any stray electricity before it can cause any harm.
Yeah, you got it.
Yeah.
But even with these earthing systems in place, we've got another layer of protection, and that's where those RCDs come in. RCDs, or residual current devices. Ah,
yes, RCDs. I've seen those little things in the bathroom, in the kitchen, usually got that little test button on them. But I have to admit, I've never been totally clear on how they actually work. I mean, it's not like they've got tiny little sensors that can detect water, right?
No, not exactly. They're way more clever than that. RCDs are constantly monitoring the balance of electricity flowing through the wires. Yeah. And if they sense even a tiny imbalance, like a really small amount of current escaping, that could mean it's going through a person. Or, there's a fault somewhere. And that's when the RCD trips. It cuts off the power almost instantly.
It's pretty amazing when you think about it. These little devices, these RCDs, they've probably saved countless lives. I mean, before they were common, even a minor electrical fault in the bathroom that could be fatal. They've really changed the game in terms of electrical safety.
Oh, absolutely. And that's exactly why BS 7671 is so specific about RCD protection, especially in areas like bathrooms and kitchens, and especially around swimming pools. Because water just dramatically increases the risk of electric shock. So those areas need that extra layer of protection, no question.
It's interesting, speaking of bathrooms, I noticed something in the standard that I thought was kind of curious. It specifically says that you can't have single pole switches in the neutral conductor. What's the deal with that? It seems like such a small detail.
You'd be surprised. It might seem small, but it's actually a really crucial safety measure. So imagine you had a single pole switch in the neutral, right? And you flipped it off. Now the circuit, it might look dead, but the live conductor, that would still be energized.
Oh, wow. So you might think everything's safe, but you're actually just like one touch away from a potentially deadly shock.
Exactly. And that's a perfect example of how even these seemingly minor details in BS 7671, they can really make the difference between safety and, well, a very hazardous situation.
It's all about the details, isn't it? Now, we've talked about shocks, but it's not just shocks that we need to be worried about, right? I imagine electrical installations, they can also be a major fire hazard.
Well, absolutely. You're spot on. That's where Chapter 42 of BS 7671 comes in. It's all about protection against thermal effects.
Right.
We got to remember that electrical components, they can overheat. And if they overheat too much, that can spark a fire. And then on top of that, you've got the risk of arcs and sparks, from faulty wiring or equipment.
Okay, so we're talking about a double whammy of potential fire risks here. Heat from the components themselves and
Right.
sparks coming from faulty wiring or equipment.
Exactly.
So how does BS 7671, how does it tackle these fiery situations?
Well, the focus is really on prevention. Rather than, putting out fires, it's about stopping them from starting in the first place. So BS 7671, it mandates the use of non-flammable materials for wiring systems, for enclosures, all of that. The idea to limit the spread of fire if one does break out.
So thinking ahead, basically.
Yeah, exactly. And this is really important when it comes to, the choice of materials. Like steel, for example. Steel is considered to have limited smoke production, which is crucial, right? Because if there is a fire, you want to maintain visibility. You want people to be able to escape safely.
Wow, I never even thought about that. So even the choice of materials can have a big impact on fire safety.
Oh, absolutely. But beyond materials, there's also this kind of new thing. They're called AFDDs, arc fault detection devices.
AFDDs, those sound kind of futuristic.
I know, right? It's like something out of a movie. But their function is actually pretty simple. They detect dangerous arcing faults, the kind of things that regular circuit breakers might miss. So they're providing this extra layer of protection against fires, caused by those hidden electrical gremlins.
Okay, so that's good to know. So we've got earthing systems to prevent those shocks.
Right.
We've got non-flammable materials and these AFDDs to protect against fires. It sounds like BS 7671 is building a pretty solid defense against electrical hazards.
Yeah, it really is. It's like a multi-layered approach to safety.
Yeah.
But we got to remember, electrical installations, they're complex systems. And to really understand how all these safety features work together, we need to dig into the basics, how electricity is actually distributed throughout your home. And that brings us to Chapter 31 of BS 7671, which focuses on, you guessed it, circuits.
Okay, so now we're getting into the nitty-gritty of how electricity actually flows through our homes. Now, I've always been a little bit confused about circuits. Why do we need multiple circuits in the first place? Why can't we just wire everything on one giant circuit? Wouldn't that be simpler?
Well, it might seem simpler on the surface, but imagine this, right? Your entire house, everything, wired on one circuit. And then one appliance goes faulty, just one. Boom, your whole system could go down.
Oh, wow. That would be a nightmare, especially if you're in the middle of cooking dinner.
Exactly. Or you're trying to meet a deadline working from home. So that's why BS 7671, it really emphasizes dividing installations into multiple circuits. It's not just about being organized. It's about safety. It's about preventing those cascading failures. Each circuit acts like its own little compartment. So if there's a problem, it's isolated. It can't spread to the entire system.
So circuits are kind of like those fire doors you see in buildings, containing any electrical fires and stopping them from spreading to the whole structure.
Yeah, that's a great way to think about it.
Yeah.
And speaking of containing problems, the next step is making sure you're using the right equipment for each circuit. And that's where Chapter 51 comes in, selection of equipment.
That reminds me of those warnings you see about, like, not using indoor extension cords outside.
Exactly.
Yeah.
Simple example, but it illustrates the point perfectly. You wouldn't use a garden hose to, pump water into your house.
Right.
You need the right tool for the job. And that applies to electrical installations just as much as anything else.
So it's not just about plugging things in, it's about plugging them in safely and using equipment that's designed for that specific purpose.
Precisely. BS 7671 wants to make sure that the equipment you're using, it can handle the demands placed on it. It can operate safely within its intended environment. Like, you wouldn't want to plug a high-powered appliance into a flimsy little extension cord, would you?
Definitely not. That brings back some not-so-fun memories of college dorm life. But speaking of equipment and its limitations, I noticed something interesting about equipment connected to conductors operating above 70 degrees Celsius. Why does that temperature require special consideration?
That's a great question. Because high temperatures, they can really do a number on insulation and materials over time. It can lead to premature failure, even fire risks. Like, imagine a wire getting so hot that it melts its insulation. That's not a good situation.
Yeah, that doesn't sound good at all. So it's all about making sure the equipment can handle the heat, literally.
Literally, yeah.
It's fascinating how much thought goes into making these electrical installations safe.
It really is. But here's the thing, right? BS 7671. It's not a static document. It's not set in stone. It's constantly evolving.
Yeah.
To keep up with new technologies, changing energy landscapes, all those evolving safety concerns. And that's why it's so crucial to stay updated, especially with the 2018 amendment and all the revisions that have come since then.
Yeah, you're right. I'm particularly interested in those 2018 updates. It seems like that's when the standard really started grappling with this whole rise of home energy systems, like solar panels, batteries, all that stuff.
Absolutely. It was a big turning point.
What were some of the key changes there?
Well, that's a great question. And that's a perfect place to pick up when we come back for part 2 of our deep dive.
All right, sounds good. I'm definitely intrigued. We'll be back soon to delve deeper into the world of BS 7671. Don't go anywhere.
All right, welcome back to our deep dive into BS 7671. So before the break, we were talking about how the 2018 update started to address this rise of prosumers. Those folks who are both producing and consuming electricity, often through things like solar panels, right?
Exactly. It seems like it's a whole new world of complexity for electrical installation.
It really is, yeah. And you're right, that 2018 update, that was a big moment. That's when BS 7671 really started to adapt to this new energy landscape, specifically with the introduction of Chapter 82.
Right, Chapter 82.
Which is dedicated to, prosumers electrical installations, or PEIs.
PEIs, right. I remember you mentioning that earlier. But before we get into the specifics of those regulations, can you just paint a picture for me? Like, what makes these prosumer setups so different from traditional electrical installations? What are the unique challenges that they bring to the table?
Well, I think the biggest shift is the flow of electricity. In a traditional setup, electricity flows one way, right? From the grid into your home.
Makes sense.
But with prosumers, things get a little more, dynamic. The electricity can actually flow both ways.
Oh, interesting.
So you might be generating more power than you're using. And in that case, you'd be feeding it back into the grid.
Like selling it back, right?
Yeah, exactly. Or, on the other hand, you might be drawing power from your solar panels during the day, and then from the grid at night when the sun's down. So this two-way flow, it creates a whole new set of safety considerations.
Yeah, I can see that. It's like a two-way street where you have to be extra careful about potential collisions.
Exactly.
So how does BS 7671, how does it address this increased complexity? How does it make sure things are running smoothly and safely?
Well, let's start with something we often take for granted. Power outages.
Okay, power outages, yeah.
So imagine the grid goes down, right? But your solar panels are still happily generating electricity. Now, without the proper safeguards in place, that electricity could actually backfeed onto the grid.
Oh, wow.
And that could be really dangerous for utility workers because they're assuming those lines are dead.
Yeah, that's a scary thought.
It is. It is. It's like accidentally electrifying a road that everyone thinks is closed for repairs.
Exactly.
So that's why Regulation 826.1.3 is so important. It outlines very specific requirements for PEIs during grid outages.
Okay, so what are those requirements?
Basically, the system needs to either disconnect from the grid completely, forming what they call an island mode.
Island mode, okay.
Or it needs to shut down all the local power supplies. So either way, you're creating a clear separation, preventing any backfeeding onto the grid.
So it's all about creating those clear boundaries, making sure there's no confusion about where the electricity is flowing.
Exactly.
Now, what about another potential hazard that we talked about earlier, short circuits? Does the two-way flow of electricity make those more complicated as well?
Absolutely. In a traditional setup, you'd mainly be worried about short circuits originating from within your home.
Right, right.
But with prosumers, a short circuit could originate either within your home or on the grid itself.
Oh, I see.
So the protective devices, like your circuit breakers, they have to be prepared to handle faults coming from either direction.
So they have to be like extra vigilant.
Exactly. And Regulation 826.1.1.3, it's very specific about this. It says that the protective device has to be chosen based on the worst case scenario, considering the combined short circuit current from all potential sources.
So it's like planning for the worst, hoping for the best.
Yeah. You got it.
I'm starting to see how PEIs, they're really like a puzzle where all the pieces have to fit together perfectly to ensure safety and reliability.
That's a great analogy. And just like with a puzzle, there are specific rules and guidelines to follow. And that's what BS 7671 provides. It helps make sure those PEIs are designed and implemented in a way that's safe efficient, and most importantly, compatible with the grid.
We've talked about power outages, we've talked about short circuits. What other unique challenges do these home energy systems throw into the mix?
Well, another big one is energy storage. You mentioned homeowners installing batteries to store their solar energy, right?
Yeah. It's like having your own little power plant, storing up sunshine for a rainy day.
Exactly. But while batteries are super useful, they do add another layer of complexity to the system.
Okay, how so?
Well, one thing BS 7671 highlights is the inrush current of batteries.
Inrush current.
Yeah, it's a bit of a technical term. But basically, when you first connect a battery, there's this sudden surge of current as it starts charging.
Oh.
It's like trying to fill a bathtub with a fire hose. You need to control that initial flow to avoid overflowing or causing damage.
Right, that makes sense.
And Regulation 826.3, it addresses this specifically. It emphasizes the need to account for that inrush current when designing the system, making sure the wiring and the protective devices can handle it.
So it's not just about managing the steady flow of electricity, but also those sudden bursts of energy.
You got it.
Now, what about those transitions between, like, using the grid versus using the battery backup?
Another great point. That smooth transition between different operating modes, that's crucial. Like, if the grid goes down, your system needs to seamlessly switch to that island mode we talked about, powering your home from your battery backup. And you want that to happen without any hiccups.
Right, you don't want the lights to flicker or anything.
Exactly. And BS 7671 provides guidance on how to manage those transitions, making sure the voltage and the frequency remain stable so, your appliances are protected, and it's a smooth ride for you.
This is all incredibly fascinating, but I gotta be honest, it's also a bit overwhelming. There are so many things to consider with these home energy systems.
It's true, it's a lot to take in.
It seems like BS 7671 is trying to anticipate every possible problem and provide solutions.
Yeah, that's a good way to put it. It's like a comprehensive guidebook, helping you navigate the complexities of modern electrical installations, especially in this new world of prosumers and home energy systems.
Now, speaking of comprehensive guides, it seems like BS 7671 is focused on more than just safety, right? Earlier, you mentioned energy efficiency. How does that factor into these regulations, especially when it comes to prosumers?
Well, energy efficiency is a key consideration throughout BS 7671, not just in Chapter 82. The goal is to minimize waste and make sure installations are operating as efficiently as possible.
Okay, that makes sense. But can you give me some specific examples? Like, how does BS 7671 actually encourage energy efficiency?
Sure. So one example is the recommendation to limit voltage drop within an installation.
Voltage drop. Okay.
Voltage drop is like losing water pressure in your pipes. It means energy is being lost along the way.
Oh, I see.
And BS 7671, it provides guidelines for minimizing that voltage drop.
Yeah.
So that more of the electricity generated, whether it's from the grid or your solar panels, more of it actually reaches your appliances.
So it's like making sure your electrical pipes are the right size to deliver the energy efficiently.
Exactly. Another way BS 7671 promotes energy efficiency is by encouraging the use of energy-efficient equipment. Remember, Chapter 51, the one about selecting equipment?
Yeah.
Well, it stresses the importance of choosing equipment based on its energy consumption characteristics. So it's kind of nudging consumers and installers towards appliances and devices that use electricity wisely.
That makes sense. It's like aligning the standard with this whole push towards energy-efficient appliances that we're seeing everywhere.
Yeah, exactly. And this focus on efficiency, it extends to specific applications too, like solar PV systems, for example. Section 712. That's all about optimizing their performance, making sure they're squeezing every last drop of power from the sun.
So BS 7671, it's not just about making things safe. It's about making them work smarter, more efficiently.
Precisely. It's about ensuring that electrical installations are both safe and sustainable for the long haul.
This is all incredibly insightful, but it's clear that we've only just scratched the surface of this vast world of electrical regulations.
You're absolutely right, but I think even just scratching the surface, it reveals a wealth of information, a lot of fascinating insights, and it highlights how BS 7671 is constantly evolving, adapting to new trends and technologies, really shaping a safer and more efficient electrical future for us all.
Well, on that note, I think it's time to move on to part 3 of our deep dive. When we come back, we'll dive into some of the specific sections of BS 7671, the ones that deal with, unique environments and applications. Stay tuned. All right, welcome back to the deep dive.
So we've been on quite a journey through the world of BS 7671, exploring how this standard keeps us safe from those electrical hazards and making sure our installations are, not just safe, but efficient too.
Yeah, absolutely. We've covered a lot of ground, that's for sure. From the basic principles of protection, like those shocks and fire hazards we talked about, all the way to the more complex stuff, like prosumers and smart homes, right?
Right.
But before we wrap up this exploration, I think it's important to touch on how BS 7671 deals with, different environments. Like electrical installations aren't one size fits all, right?
Right.
You got to think about the specific risks in different places. And it seems like BS 7671, it really goes into detail about those nuances.
Yeah, it's pretty impressive. So what kind of environments are we talking about? Well, let's start with a classic example. Swimming pools.
Okay, swimming pools, yeah.
Water and electricity. Not a good mix.
Definitely not.
So, Section 702 of BS 7671. That lays out some pretty strict rules specifically for swimming pools and other basins.
Okay, so we're going beyond just having those RCDs in the bathroom. What kind of specific measures are we talking about here?
Well, think about it. You've got people splashing around, right? Maybe getting water on electrical equipment or even accidentally dropping something into the pool.
Yeah.
The risks are pretty high.
Yeah, that makes sense. So what's the approach?
Well, BS 7671 takes what they call a zoned approach. It's like, imagine drawing circles around the pool.
Okay, circles, I'm visualizing.
So zone 0, that's the area inside the pool itself.
Inside, in the water.
Yeah, right in the water. And in that zone, only specialized equipment is allowed, like stuff that's designed to be underwater. And it has to be, ultra protected.
So no plugging in your underwater disco ball?
No, definitely not.
All right, what about outside the pool?
So then you've got zone 1, which extends a certain distance around the pool's edge. This zone, it also has strict requirements. The focus is on equipment that's got a high degree of protection against water.
Okay, so like waterproof enclosures and stuff.
Exactly. And then you've got zone 2, which extends further outward. It still needs safety measures, but they're not as strict as the inner zones.
So it's like a fortress of safety, basically, with the defenses getting stronger as you get closer to the water.
That's a great way to put it, yeah. This zoned approach, it makes sure that every part of the pool environment is protected, keeping swimmers and everyone else safe.
Now, swimming pools aren't the only places that need this kind of special attention, right? What about, like, construction sites? Those seem like they'd be a whole other level of electrical hazard.
Oh, you're absolutely right. Construction sites, they're dynamic, they're unpredictable. You've got temporary wiring everywhere, heavy equipment moving around.
Yeah, it's a lot to keep track of.
It is. But luckily, Section 704 of BS 7671, that tackles these challenges head on.
Okay, so what are we talking about here? Is it just like using heavy-duty extension cords?
Well, it's more than that. You got to think about the wear and tear on the wiring. I mean, it could be exposed to the elements, dragged across rough surfaces, even accidentally hit by machinery.
Oh, that makes me cringe just thinking about it.
Yeah, it's not pretty. So BS 7671, it requires these really robust wiring systems for construction sites.
Okay, robust, meaning?
Well, we're talking about cables with steel wire armor or, tough sheeting to prevent that kind of damage.
Like giving the wires their own safety gear.
Exactly. And of course, RCDs are mandatory for all socket outlets, providing that extra protection against shocks, especially since construction sites are often, wet or damp.
Yeah, that makes sense. Safety first, always.
Absolutely.
Yeah.
And BS 7671, it doesn't stop there. It also addresses other hazards specific to construction sites, like the risk of coming into contact with overhead power lines.
Oh, yeah, those are dangerous.
Very dangerous. So the standard, it mandates clear safety distances and procedures to prevent workers from, accidentally touching those lines.
So it's like a whole set of rules specifically designed for those environments.
Exactly.
It's amazing how BS 7671 anticipates all these potential hazards.
It really is.
And provides safeguards for such a wide range of environments.
And it's not just about specific places either. It also covers different types of installations.
Oh, okay. Like what?
Well, for example, Section 710. That's all about medical locations.
Medical locations, right. Yeah, those are places where electrical safety is absolutely critical.
Absolutely. I mean, you can't have any malfunctions or power outages, especially when people's lives are on the line.
So what kind of special measures does BS 7671 have for hospitals and clinics?
Well, in medical locations, the risk of electric shock, it's even greater because you've got patients who might be connected to, life support machines or other sensitive equipment. Any stray current, that could be devastating.
So how do they address that?
Well, one key measure is the use of these specialized medical IT systems. which are basically isolated electrical circuits. They're designed to minimize the risk of those stray currents.
Okay, isolated circuits, got it.
And these systems, they also have sophisticated monitoring devices. They're constantly checking for insulation faults. And they'll trigger alarms if anything goes wrong.
Wow, that's impressive. So it's like a whole other level of protection.
It really is.
Yeah.
And BS 7671, it doesn't stop there. It even addresses specific areas within medical locations, like operating rooms, which have even stricter requirements because of, the presence of flammable anesthetics.
Right, of course.
So you can see a lot of thought has gone into making these environments safe, considering all the potential risks.
It's clear that BS 7671 is, it's more than just a set of rules.
Yeah, it's a framework.
Yeah.
And it's constantly evolving, adapting to new technologies, to emerging challenges.
Like we've seen throughout this whole deep dive. It's addressing those complex prosumers, the security concerns with smart homes, the unique hazards of all these different environments. It seems like there's no challenge too big or too small for BS 7671.
And that's why it's so important to stay informed. Keep up with the latest updates and developments. That's how we make sure our installations are safe, efficient, and compliant.
Well said. I think we've given our listeners a pretty good overview of this standard.
Yeah, we've unpacked the core principles, explored those different applications, and I think most importantly, we've highlighted that this is a field of continuous learning.
Absolutely. So whether you're an electrician, a homeowner, or just someone who's curious about, the electrical systems that power our world, I hope this deep dive has been insightful and empowering.
And remember, knowledge is power. Stay curious, stay informed, and most importantly, stay safe.
Couldn't have said it better myself. Well, that's a wrap for this electrifying episode of The Deep Dive. Thanks for joining us, and we'll see you next time for another deep dive into a new and exciting topic.